Okay, here is an example. And I'm going to begin with testing the mean hypothesis, which is your section 10.3. So here is the example. The Center for Disease Control reported on trends in weights, heights, and body mass index from 1960 through 2002. The general trend was that Americans were much heavier and slightly taller in 2002 as compared to 1960. Both men and women gained approximately 24 pounds from 1960 to 2002. In 2002, the mean weight for men was reported to be 191 pounds. So the average weight is 191 pounds. Suppose that an investigator hypothesizes that weights are even higher in 2006. We want to study this claim. So somebody is making a claim that the weights even are higher than what they were in 2002, which is 191 pounds. So let's state first of all the null and the alternative hypothesis. And let me show you how that works. So we're going to state it right here. HO and HA. Okay. So it's about the mean. So the investigator is saying it's more than 191 pounds. And what would be in the null hypothesis equal 191 pounds. And this is where the claim is. Let's continue on reading. You see a lot of text here. I put the text. Usually the problem is much simpler than that, but I'm trying to explain the first example well to you. In order to test the hypothesis, we select a random sample of American males in 2006 and measure their weights. So we selected 100 individuals. Their sample mean weight was 197.1 pounds, and the population standard deviation of the weights was 25.6 pounds. Do the sample data support the investigator claim? So we need to check if we can support the claim or not. Use a 5% level of significance. As I explained to you earlier, the level of significance is the maximum allowable probability of rejecting the null hypothesis when it is true. Okay. Let's see if we can do this one without doing the test, but actually not. The sample mean of 197.1 is actually higher than the 191. So does that mean that yes, people on average are they gain more weight from 2002 to 2006? Well, the difference between 197.1 and 191 is 6 pounds. Is 6 pounds, just a significant enough weight to say that yes, it does make a difference, to say that people are gaining more weight? We don't know. That's why we have to perform a hypothesis test. So, however, is this difference more than what would be expected by chance? So maybe this difference was happened by chance. We just happened to pick, just this group, and they were by chance a little bit overweight, than others. So we don't know. That's why we need to perform a hypothesis test. So the first step, guys, is to state the null and the alternative hypothesis. This is step 1. Step 2 is to convert, the data that was given to you to a test statistic Z, which is called Z. We call it Z when the population standard deviation is known, and we call it T when the population standard deviation is not known. The formula for Z is the following. It's just a Z-score that you learned in previous chapter. It is the sample mean minus the actual mean that we assume it's 191 until proven otherwise, divided by the standard deviation. But since we are working with samples, the standard deviation from your chapter 7 is not sigma, it's sigma over square root of n. I will provide this formula. However, guys, you don't need to use it. I'm going to show you when we do this on the calculator that there is no need to use this formula. So that will be 197.1 minus. What do we use for the mean here? We assume that the null hypothesis is true until proven otherwise. So 191 divided by sigma, which is 25.6 over square root of 100. And if you do your math, it's going to be 2.38. So this is step number 2. Step 3. which is the p-value. Let me explain what the p-value is. Remember, this is a right tail test. So the p-value here is this. You draw the normal curve. This is the test statistic Z 2.38. You put it here. And since this is a right tail test, you shade the area to the right of Z. The p-value is the probability that Z equals 2.38 or higher. So what is the probability of observing a value as extreme as 2.38 that we got from the sample or more extreme? You need to find this area. You can do it using the normal CDF formula that you use in chapter 7. You need 4 arguments: the lower bound 2.38, upper bound 1,000,000, and then 0, 1 because we're using Z here. So what would be this value? If you put it into your calculator, it's going to be 0.0086. So this is the p-value. You'll see later that you don't have to do this by hand. The calculator also will do it for us. If this was a left tail test, you will put the Z on the left, it will be negative, and then you do the area to the left. So it depends on whether you have a right tail test, a two tail test, or a left tail test. So the p-value here is 0.0038. Now, how do you make a decision to reject the null hypothesis or fail to reject the null hypothesis? You're going to need to memorize this. If the p-value is less than alpha, we reject HO. And if the p-value is more than alpha, we fail to reject HO. What is it in our case? My p-value is 0.038, and you guys agree it is less than alpha, which was given in the problem as 0.05, 5% level of significance. So what's my decision here? My decision is the p-value is less than alpha, we reject HO. So that's step number 4. Now, the last step. Write your conclusion in the context, just of the claim. Step 5. Do you support the claim or you don't support the claim? And let me show you how to write this conclusion now. Okay, we rejected the null hypothesis. Here's the null hypothesis, guys. Let me show it again to you. This is the null hypothesis. We rejected it. And the claim is in the alternative hypothesis. Well, if you reject the first one, that means the second one must be good. Then you end up supporting the claim. So this is what you write. You write, there is enough evidence at the 5% level of significance to support the claim. And whatever the claim is, you just write it down, guys, that that weights are even higher in 2006. Are higher in 2006. That concludes the problem. Now, if you want to do it using technology, let me show you how you could have done this problem using the calculator. Okay, for step 1, guys, you have to know it yourself. The calculator is not going to do the first step for you. But let me show you how you can do the rest. When you test the mean and when the population standard deviation is given, you must use a test called z-test. So I'm going to go to tests, and it's the first one, z-test. Okay, you have a summary of the data, so it's stats. Okay, and let me walk you through the steps here. The first step is, it says mu0. It's asking you what was the value from the null hypothesis, which is 191. So you put 191. Enter. It asks you for sigma, which is population standard deviation, 25.6. Enter. It's asking you for X bar, which is now 197.1. Enter. It's asking you for the sample size, which is 100. Enter. One more step. The last step, guys, is to decide which one of those symbols is the alternative hypothesis. You know the alternative hypothesis is greater, so you choose this one. Greater than. And then you go to what? Calculate. And look what you got as a result of hitting calculate. You got step number 2, which is Z2.38, which we did some math to find it, and we got the p-value, which is 0.00859. If you do it to 4 decimal places, will be 0.0086. So your calculator will give you the most important steps, step 2 and 3. It will give you the p-value, and then whatever the p-value is, guys, if it is less than alpha, you reject HO. If the p-value is greater than alpha, you fail to reject HO. Let's assume the p-value in this exercise was bigger than alpha and we fail to reject HO. What do we write at the bottom? We don't say that we support the claim, because we ended up not rejecting HO and the claim happened to be in HA. If you cannot reject HO, you cannot support the claim. So you say there is not enough evidence to support the claim. So this is the first example in how to perform a hypothesis test for the population mean when population standard deviation is known.